Alrighty, so we're going to go over the review section of our textbook. So this is section R1, sets and interval notation. So if you go to the lecture slides on Pearson and also on Lima, they go more into depth on sets as well as the intersection and union of sets, um, but not as much on interval notation. So we're just going to go over that in this video as well as touch on the intersection and union of sets too. So we're just going to get into it with some examples. The first example we're going to look at is the inequality x is greater than 4. So a good idea whenever looking at these is to try to visualize what's going on the number line. So we're going to start out by drawing our number line. And so this notation here is that x is strictly greater than 4. So we notate this by using a parenthesis. So it's strictly greater than 4, but not equal to 4. And so we're looking at all these values that go on here. And in interval notation, this looks like we're going from 4, but not including 4, all the way up to infinity. Now, we also use parentheses when we're talking about infinity or negative infinity because we're never actually going to reach that number. So we are always using a parentheses with negative infinity and positive infinity. All right, let's look at another example. We have x is less than or equal to negative 1. Now here we see that x is less than or equal to, so we're going to be using a bracket. So drawing our number line. And then we know that x is going to be less than or equal to negative 1, so we have our bracket here. And we're looking at all these values and so on. And then in interval notation, I'm just going to abbreviate that as IN, we have negative infinity, and again, we're using the parenthesis, all the way up to negative 1, and we're including negative 1, so we're using our bracket there. All right, let's look at another example. In this example, I'm saying that x is going to be greater than or equal to 1, but less than 3. Again, we want to look at our number line. So let's put some numbers around 1 and 3. Now, we said that x is greater than or equal to 1, so we know that we're going to have a bracket here. But x is less than 3 and not including 3. So we have our open parenthesis here. So this interval is all these values in this region here. And then in interval notation, this will be 1 to 3. All right. Now, we should also be able to be given an interval and use that to determine what the inequality is. So for our next example, we're going to be given the interval negative 1 to 2. Now, again, let's look at our number line. All right, so we're saying our interval is from negative 1, but not including negative 1, all the way up to and including 2. So all of the values in this region here. And then from this, we know what our inequality will look like. And that's values of x that are greater than negative 1, but not equal to, and less than or equal to 2. Okay, so we can also use inequalities to represent real-world information. So let's look at this following example. Suppose that we let our variable x be equal to the average rainfall in Hawaii in inches per year, and we're told that Hawaii averages between 25 and 30 inches of rainfall per year. So what we can do is we can write this information as an inequality, and it looks like this here. And this just means that x is between 25 and 30. And I just want to point out here that this notation, x is strictly greater than 25 and strictly less than 30. And this is because of the terminology that we're using, or I guess not using in this case. And that is, if we were told, for example, that there is at least 25 inches of rainfall per year, then x would be greater than or equal to 25. And then if we were told that there is at most 30 inches of rainfall per year, then x would be less than or equal to 30. So I just wanted to point out when we do and don't use that notation in these kinds of examples. All right, now we're going to switch gears a little bit and talk about the union and intersection of sets. So we're going to do this, we're going to switch gears a little bit, and we're going to do this by looking at a few examples. So let's look at this intersection of the set. And this set here. And so all of the numbers in these sets are elements of the set. And so when we're looking at the intersection of these sets, we want to see what elements they have in common. So just looking at this, we see that both sets have a 5, and both sets also have an 8. Now there's nothing else, no other elements they have in common, so the intersection of these two sets is just this here. Right? Now let's look at another example. Let's look at the intersection of these two sets here. Now again, we want to see what elements these two sets have in common. And if you notice that there aren't any elements that these two sets have in common. So we say that the intersection of these two sets is equal to this notation here, which is a 0 with a slash through it, and that's what's called the empty set or the null set. Now, you might see some examples like this on your homework, and so this is a fine answer to put. We're just going to use this notation in this class and with MyLab math. All right, now let's look at an example of the union of two sets. So let's look at this set here. So when looking at the union of sets, we just are essentially combining or unioning the elements of the set. And whenever we do this, we do want to list the elements in increasing order when we have sets like this. So as you can see, we have this 1 here is an element of the second set, so we'll put that there. We also have a 3 in this set and a 3 in this set, so we're going to put our 3 there. And we don't want to repeat elements, so even though there's a 3 in both sets, we only want to write it once for our answer here. And then since we're writing it in increasing order, we're going to have our 4 and our 6 from our first set and our 7 from our second set. And that is the answer for this one. And what we want to look at is using intersection or union with our interval notation. So we'll look at the following example. Okay, so we have the union of two intervals. And so what we're going to do first is we're going to draw two number lines here, how we were doing in the beginning of this video. So our first interval here, -1 to 2, we're looking at values from -1, but not including, all the way up to 2, but not including 2. So all values in this region here. And then for our interval 0 to 3, also going to draw our number line. And we're looking at values from 0 and including 0, all the way to 3, but not including 3. So all of the values in that region there. And so when we're taking the union of these two intervals, we're just combining everything. So we can look at one combined number line. And we can see that we're starting from -1, but not including, and going all the way up to 3, but not including 3. So all of the values in this region here. And we just get that by combining these two intervals. And then this ends up being the interval from -1, but not including, all the way up to 3, but not including 3. All right. Now, the last thing we will talk about, move this up a little bit, is set builder notation. So an example of this is the following. And this is what's called set builder notation. And what this translates to exactly is that we have some x values. Sorry, I abbreviated that, but let's just write it out. X such that x is less than 3 and greater than or equal to 7. All right, so we can actually write this in our interval notation, right? We're saying all values that are strictly less than 3, right? So this will be all values from -infinity up to 3. And we are using our intersection because of this term here. We're looking at all values less than 3 and greater than or equal to 7. So our second interval is going to include 7 all the way up to infinity. All right, so as you can see, this actually will be equal to the empty set because there are no elements in common. And we can actually look at our number line here. So we have our first interval is saying all values less than but not including 3, and so on. And then our second interval is saying all values greater than 7 and including 7. So all of these values and so on. And as you can see, there's nothing in common. These two intervals have no elements in common, so we are left with just the empty set. All right, so I think that's it for this section.